Section 6.2 involves the normal distribution in variable x. This diagram is a reminder of the empirical rule and the symmetry that you see. We are dealing with an x-axis now, and remember the variable x is continuous, like height or weight is measurable. The mean of that population will always be at the center. And then the empirical rule, one standard deviation is 68.2, 95% approximately for 2 standard deviations, and 99.7% for 3 standard deviations. So this is what the empirical rule once again looks like for the normal distribution in variable x. So I'm going to remove this diagram. These are the lecture notes. As a reminder, these lecture notes pertain to using the one-page z-table. So the purpose of this Tegrity video is to show you the 2-page z-table. And these are big problems. For example, the test score for a certain exam are normally distributed with a mean of 100 and a standard deviation of 15. Find the probability that a person's score falls above 79. I'm going to show you how to answer these questions by hand and calculator. By hand, we have to go from x to z. Remember, for every data value x, there is a corresponding z-score. The z-score is its measurement of position. Where does x fall above or below the mean? Not only where does it fall, but how many standard deviations does it fall above or below the mean? So we will answer these questions, and these are true life, real life situations, application problems. This is the one-page z-table, which we will not use today with the video. Again, I remind you of the calculator tips. We will be here, normal distribution in variable x, normal CDF, smaller x, larger x, the mean, and the standard deviation of the population. This is if you want to find probability, if they give you x and you're finding area or probability. And then if you're finding a cutoff on the x-axis, an unknown cutoff, then you put in the area below the unknown x, the mean, and the standard deviation. So I will show you how to use normal CDF and invert the norm for a normal distribution in variable x. So both of those commands are going to be very handy. Now, the background information once again before we start working the problems. Recall for every value x in a data set, there's a corresponding z-value using the famous z-score formula, and that's x minus mu over sigma. Mu is the population mean and sigma is the population standard deviation. The z-value for x represents the number of standard deviations that x falls above or below the mean. It's a measure of position. Your job by hand is the successful change from a normal distribution in variable x to a normal distribution in variable z. And how do we do that? The famous z-score formula. So we're going to go from this in x to this in z so that we can use the 2-page z-table to answer the questions and find the area or find the cutoff. So that's the first page. The second page, why? This section involves major word problems dealing with probability, and probability equals area under the curve. Once we successfully change from a word problem in x to a word problem in z, we can use the z-table to find area under the curve and thereby probability. So the word problems are going to begin problem number 1. Again, as you read through these on your own, you will see that these pertain to the one-page z-table. I'm going to show you how to work the majority of these problems using the 2-page z-table. So I will remove these lecture notes. Question number 1. And let me enlarge this so you can see it. The test scores for a certain exam are normally distributed with a mean of 100 and a standard deviation of 15. Find the probability of a person's score falling above 79. So this is what we would do. We would write down what was given and what they asked us to find and then draw the picture. This is standard process for any word problem. Given. The mean of a distribution of test scores is 100. and the standard deviation is 15. Find the probability that a student's score falls above x equals 79. Now, notation-wise, this is the probability that x is greater than 79. I'm going to draw the mean and put the 100 at the center. And again, this is the x-axis and it's test scores. Okay? When we have the mean in the picture, it's easy to put the 79 where it should fall on the axis. 79 is below the mean, so therefore its z-score is going to be negative. But we wish to find the probability that a person's score falls above 79, so I shade all of this area. This area is the probability, which is the answer to our question. So the next step, after you write down what you're given and what they ask you to find and draw the picture, you got to change to z. I will say one more thing about what's given. Notice that we do not know the population size. And we do not know the raw data, all the test scores, all of those x's. But we do wish to find the probability that a student's score falls above a grade of 79, which is x equals 79. So, the next step, find the z-score. And this is if you're working these by hand. Z is x minus mu divided by sigma, 79 minus 100 divided by 15. And you will round that to two places. And that's a negative 1.40, which actually does not need to be rounded because it's exactly negative 1.40. This means that this 79 is a 1.4 standard deviation below the class average. 1.4 standard deviations below the class average of 100. 1.4 standard deviations below the class average. It's a measurement of position, 1.4 below. Below is the negative. Negative 1.4 below. And that makes sense. So, what we would do is the next step. We would go to the standard normal distribution. And here it is. And I need to indicate a negative 1.4. And this is where it falls approximately. And what I'm going to do is I'm going to shade the area above it. So, this is the normal distribution in X. This is the standard normal distribution in Z. I have a score of 79, and its z-score is negative 1.4. Excuse me, I put negative 0.04. That's a big difference. What I am saying is that the probability that x is above 79 is equivalent to the probability that z is greater than a negative 1.40. So the probability that a randomly selected z on the z-axis falls above negative 1.40 is the same as the probability that a test score x falls above 79. So if we can find this area with the z-table, then we have our answer to the question. So we're going to look up a z-score of negative 1.4. And here it is. 0.0808. 0.0808. That area is actually this area. So the area that I want to find is this. But the area the table gives me is 0.0808. So the answer to the question is going to be the total area under the curve, take away the 0.0808. And that would leave the area in red, which is the area we are trying to find. And that is 0.9192, or 91.92%. Therefore, I'm going to go back to this question. The probability that X is greater than 79 is 0.9192, or 91.92%. Either one is acceptable because it's probability. So that's the process by hand. Now the calculator. With the calculator, and I'll start off by showing you the most updated version. Go to second variable and go to number 2, normal CDF. This time we put in, according to the tip sheet, the smaller x, the larger x, the mean, and the standard deviation. So the smaller is 79, the upper is E99. That says that the area goes all the way out to positive infinity. The mean is 100 and the standard deviation is 15. We do not have to use z at all if we're using the calculator. We do not need the z table at all. Everything is in terms of variable x, even the mean and the standard deviation. So press enter and then enter again. 0.9192 is your answer. Now the way the older version of the calculator works, you're going to need some commas. It's actually how I've stated the command here in parentheses and commas, the old edition of the calculator. So second variables, number 2, and I'm going to say 79, comma, E99, comma, 100, comma, 15. If you get those out of order, you will miss the question. 0.9192, or 91.92% is your answer. So there you have it. I know at this point you're probably saying, I love the calculator. Again, the calculator allows you to skip Z altogether. Question number 2 and 3 are going to be tied in together. The average age of CEOs at a certain company is 56 years old. The standard deviation is 4 years old. Assuming that the variable age is normally distributed, find the probability that a CEO selected at random will be between 53 and 59 years old. So I am going to write all of this out, and we are going to find this probability. By hand, this is going to involve 2 z-scores. So here we go. The given information is that the average age of a CEO is 56 years old. Standard deviation is 4 years. Find the probability that a CEO selected at random is between 53 and 59 years old. And that looks like this. So, the picture. The mean of 56 is at the center. This is x-axis, which is age. And 53 would fall here, and 59 would fall here. And then I'm going to shade the area between the two. That area is the probability that a CEO selected at random is between 53 and 59 years old. So we will then find the z-score for each. So let's take x equals 53. The z-score, x minus mu divided by sigma. 53 minus 56 divided by 4 is a negative 3/4, which is a negative 0.75. So this CEO, age 53, is 3/4 of a standard deviation below the average age of 56. And then the CEO, that's 59, x minus mu over sigma. 59 minus 56 divided by 4 is 3/4, which is 0.75. So this CEO of 59 is 3/4 of a standard deviation above the average age of 56 years old. And then that brings us to our standard normal distribution. So I would put negative 0.75, positive 0.75, and shade. And the reason I can do that, the probability that x is between 53 and 59 would be the probability that z is between negative 0.75 and a positive 0.75. So we are going to use our z-table, two-page z-table, to find this area. And we'll do that now. Let me get out the z-table. That's the one page, so I want to use the two-page. When we look up a z-score of negative 0.75, it's going to give us this area. So let's find out what that area would be. Negative 0.75. It looks like the area below it is 0.2266. 0.2266. So I will remove this. 0.2266. 0.2266. Now, by symmetry, the area above 0.75 is 0.2266. So there's more than one way to answer this question. The first way is to remember that the area below 0 is 0.5 and the area above 0 is 0.5. So if we just work with the left side of the mean, we could say the total area of 0.5 minus the area below negative 0.75, and it leaves us with this area. And this area we would double to receive our final answer. So again, we could work with just the left side. The total area below 0 is 0.5. Take away this area, subtract, leaves you with this area, double it, and you have the area that you're looking for. Or you could say total area under the curve is 1. Take away this area and this area, leaves you with this shaded area. So let me do this first. We're going to work with half of the distribution below 0. So 0.5 minus 0.2266. That is 0.2734. And that's this area in red. 0.2734. 0.2734. By symmetry, this is also 0.2734. So your answer is going to be 0.2734 plus 0.2734. Or you could just multiply by 2. So 0.5468. Now again, if you wish, you could say the total area under the curve minus this area, and you're left with the shaded area that you're trying to find, which is 0.5468. Final answer. So there's more than one way. So let me go back to the original picture here. And so this answer is 0.5468 or 54.68%. Now the calculator, you would do second variable, number 2, 53 and 59, 56 and 4, and then paste. The smaller x, the larger x, the mean, and the standard deviation. And let me try this again. I put in 53, 53. Sorry about that. 53, 59, 56, 4, and paste. There we go. Smaller, larger, mean, standard deviation. 0.5467. Now by the table we got 0.5468, but calculate a 0.5467. On the test, go for the 0.5468 or 54.68%. And I will not have this one as an answer choice, 0.5467. Just the 0.5468. Now, if you have this calculator, second variable, you'll do 53 comma 59 comma 56 comma 4 comma, close all that in parentheses. Again, it's the smaller x, the larger x, between 53 and 59, the mean and the standard deviation. 0.5467. Okay? So the calculator is much easier. Question number 3. If 100 CEOs are selected at random, approximately how many will be between 60 and 65? This is a very special question, and I would like to say that it addresses how many. First, we have to find the probability that a single CEO selected at random will be between 60 and 65, and then we multiply that probability by 100 to receive our answer of how many. I do want to address that before I show you how to do that with the 2-page Z-table. In the lecture notes, that is question number 3. And there is a rounding rule. Question number 3, that's page 6. And we're going to go through the same steps, except we're going to use the 2-page Z-table. With the question of how many, round accurately to a whole number. And the way I kind of put it is always round up to a whole number, regardless of decimal. Because it says 14.65. I'm going to show you that. But if this is people, we're not going to take part of a person. So even if it's 14.1 or 14.4, always round up. So it would still be 15 CEOs. So let me show you that. And that's the question of how many. So again, if 100 CEOs are selected at random, find the probability that, if 100 CEOs are randomly selected, approximately how many will be between 60 and 65? So first of all, here is the mean, and it's still 56 years old, and the x-axis is still age. 60 is here, and 65 is here. If we can find this area between them, that's the probability that a single CEO selected at random is between 60 and 65. And then we answer the question of how many. So given the mean is still 56 years old and the standard deviation is still 4, find the probability that a single CEO is between 60 and 65. And it's really a two-part find. Once you find that, then find how many out of 100 CEOs will be between 60 and 65 years old. So it's a two-part question. And we already have the picture. So let's work on that probability. We need the z-scores for both of those. So the CEO that's 60 has a z-score of 60 minus 56 divided by 4. 1. So the person that's 60 is one entire standard deviation above the average age of 56 years old. The CEO that's 65 don't think that turns out to be quite as nice. 65 minus 56 is 9. So this is 9/4, which is 2.25 standard deviations above the average age of 56. So we really want to find the probability that a z is between 1 and 2.25. So let me go to the standard normal distribution. Here is 1 exactly, and here's 2.25. And I want to shade between. Again, what we will do is we will find the area below z equals 1 and the area below z equals 2.25. Since the z-scores are on the same side of the mean, we'll just say the larger area minus the smaller area. So let's look up a z-score of 2.25 first. And that's going to be 0.9878. 2.25, 0.9878. So that's this. And then look up a z-score of 1.00. 1.00, 0.8413. 0.8413. And then subtract. So the answer is 0.9878 minus 0.8413. And that difference is 0.1465. So let's sum this up. This is the probability that a z selected at random will be between 1 and 2.25, 14.65%. That is also the same as the probability that a single CEO selected at random will be between 60 and 65 years old. So I'm going to write that down. .1465. Now, to answer the question of how many, you will take your 100 CEOs and multiply by .1465. And you get 14.65 CEOs. You cannot have part of a person, so you always round up, regardless of decimal, and that's 15 CEOs. Always round up. So that's the final answer to question number 3. Okay, now we're going to find cutoffs. So far with the first 3 problems, we have worked on, if we know X, we can find probability. But now they're going to give us area or probability, and we've got to find the cutoff on the x-axis. So that's going to involve invert the norm. And speaking of calculator, this previous problem with the CEOs, you would go to second variable, 60, 65, 56, 4, and paste. This is the probability that a single CEO selected at random is between 60 and 65. Now the calculator gives you .1464, and if you multiply by 100, you get 14.64, which we round up regardless of decimal, so it's 15 CEOs. So again, the final answer is 15 CEOs for this, even though the probability of a single CEO being between 60 and 65 is a little bit different than the table, .1464. The final answer is 15 CEOs. Question number 4. In order to be considered for a certain job, applicants must take a speed reading test. Only the top 15% are selected. Find the cutoff score if the mean speed is 89 words per minute and the standard deviation is 8 words per minute. So we have to find the score that you have to be considered for the job. Only the top 15% are selected. The mean is 80 words per minute and the standard deviation is 8. So here we go. This is number 4. I am going to write down what's given. The top 15% are selected for a job. The average is 80 words per minute, and the standard deviation, going back to that problem, is 8 words per minute. Find the cutoff score that will allow a person to be hired. Is basically the question. So, the mean. The mean of 80 words per minute falls at the center. This is the x-axis, which is words per minute. And we want to find the cutoff that designates the top 15%. When it says top, you will shade the right tail. And all of that is 15%, which is .0015 area. And this is your unknown x that you're looking for on the x-axis. Now, there is a cutoff formula that you're going to use to find the unknown x. And the famous cutoff formula is coming from the z-score formula. If you solve the z-score formula for x, you get z times sigma plus mu. So we know sigma is 8, and we know the average is 80, but we do have to find the z-score for the unknown x value, the cutoff. And this is how you would do it. You would take another normal distribution, and you would say the mean is 0, top 15%, and here's your unknown z on the z-axis. So the area that you look up is the area below it, which is 1 minus 0.0015, and that area is 0.9985. And that's all of this area. This area in red is 1 minus 0.0015, which is 0.9985. That's the area you look up in the 2-page Z table, 0.9985. And that area is going to be 0.9985 here. When you work your way out, you go out to a 2.9 and up 0.07. So your z-score should be 2.97. Okay? And let me go back and make a correction. I just noticed something, very, very major correction here, and I do apologize. The top 15% as a decimal is 0.15. I do apologize for that. That's going to throw off the calculations. So the top 15% as a decimal is 0.15. So this is 1 minus 0.15, and that's 85% below it. So this is below or to the left of it. So if I have 15% above the unknown z or above the unknown x, then 85% is below it. I do apologize for that mistake. Just realize that mistake. So I'm going to go in and look at area of 85%. 85%, it looks like it's closest to 0.8508. So if you look at your other choices, that's the closest one. Work out to 1.0 and up to 0.04, so the z-score is 1.04. So let me write that down. This z-score is 1.04. The z-score of 1.04 cuts off the top 15%. Now going back to this cutoff formula, you will put in 1.04 times 8 plus 80. And that's going to be your cutoff on the x-axis. So 1.04 times 8 plus 80 is 88.32. So 88.32. So if I put that in the picture, if you score 88.32 or better on this test, you could be considered for the job. That's the top 15%. But if you score below it, sorry, they're going to send you home. So top 15%. And this is your final answer. Now, calculator. You will have to do invert the norm with the calculator. And so let me get out the tip sheet if I have that handy. You will do the area below the unknown x, the mean, and the standard deviation in that order. Now the area below it is 85%. So invert the norm. 0.85 is area below. The mean was 80, and the standard deviation is 8. Notice how we don't have to be in z at all. So 88.29 is what they give you as the cutoff on the x-axis. And it is different from what we receive by hand. So 88.29. With this calculator, you would do second variable, number 3, and you would put in 0.85, comma 80, comma 8. And it has to be in that order. 85% is the area below, and 88.29. So this is what I would do on a test. 88.29 is calculator answer, but that will not be one of your choices. I'll have 88.32, or maybe just 88, who knows. A 79.56, a 87.54, and maybe a 89.01. But if you have 88.29 on the calculator, obviously the closer one is the 88.32. And that's the one you received by hand. So that was our first cutoff. Here's another cutoff that involves two cutoffs, number 5. For an educational study, a volunteer must place in the middle 50% on a test. The mean score was 100 and the standard deviation of 15. Find two cutoffs that allow participation in the study. So the middle 50% will be considered. A volunteer must place in the middle 50%. The average is 100. The standard deviation is 15. So we have our mean of 100. Here's your x-axis, and that's scores. We have middle 50%, and I'll cross that out, 0.50. 00 if you wish, 50%. So we are looking for an unknown x over here, which is below 100, and an unknown x here, which is below 100. They are two different, above 100. They are different, so I'm going to do an x sub 1 and an x sub 2, so that you know they're different. But that will allow participation, so we have to know what that's going to be. So given, you only want to consider the middle 50%. And you know the mean is 100 and the standard deviation is 15. And they want us to find two cutoffs that allow participation in the study. I'll just say that allow participation. So what we have to do is we have to use the cutoff formula twice. What I like to do is say x1 is z1 times sigma plus mu, and then a line, and x2 is z2 times sigma plus mu. So let's find the two z-scores that bound the middle 50%. So we have our z-axis, our mean of 0. Middle 50% is here. We're looking for a z1 that's negative and a z2 that is positive. So 0.5000. Now, I hope you know that each area is going to be 0.25. So this is 0.25 and this is 0.25 for the middle 50%. And also, since the area below 0 is 0.5 and the area above 0 is 0.5 by property, that makes this 25% in the left tail and 25% in the right tail. So 25% times 4 is 100%. We will look up an area of 25% in the Z table. So here we go. %25 is closest to, let's see, well, let's just check this out. We have 0.2514 and 0.2483. So I'm going to take my calculator. 0.2514 minus 0.25 is 0.0014 is the difference. And then we're thinking maybe the other one could be 0.2483. So 0.25 minus 0.2483. That's a larger difference. So the closer one is 0.2514. So 0.2514. Work your way out to a negative 0.6 and up to 0.07, negative 0.67. Negative 0.67. So this is the closest to 25% that we're going to have. And the z-scores are negative 0.67. So remove this. So this one is a negative 0.67 and this one is a positive 0.67. So the z-scores are plus and minus 0.67. Now I'm going to go back to my work here. X1 is a negative 0.67 times 100 plus 15. And X2 is a positive 0.67 times 100 plus 15. And I have that backwards. X1 is a negative 0.67 times standard deviation of 15 plus 100. Excuse me. X2 is a positive 0.67 times 15 plus 100. There we go. Much better. And I will calculate both of those. Negative 0.67 times 15 plus 100. 89.95. And then positive 0.67 times 15 plus 100. 110.05. And if you go up above to your picture, these should make sense. 89.95 and 110.05 will bound the middle 50%. And those people will be considered for the study. Any score between those two scores bound the middle 50%. Now your calculator works this way. You have to put in the area to the left of the unknown x, the mean, and the standard deviation. Let's just work on finding one of these. This is 0.2500, 0.2500. Right tail 0.2500, left tail 0.2500. We already discussed that. So to find x1 on the calculator, I hope you see that the area below it is 0.2500, 25%. 25% and 25% is 50%. 25% and 25% is 50%. And you have the middle 50%. So you would go to second variables, invert norm. 0.25. The mean is 100 and the standard deviation is 15. And then paste. 89.88, so that's different than by hand. 89.88, which is okay. It's very, very close to the 89.95. Now the other one, the area below the other unknown is 0.25 plus 0.25 plus 0.25, which is 75%. And that makes sense because 25% is above it, so 75% is below it. So that answer, 0.75, and paste. 110.12, which is very close to the 110.05. So these are the two answers with the calculator, 89.88, 110.12. And I did round to two places accurately, because the cutoff formula gave us two places accurately. But as far as the test, these will be the A, B, C, D options that you'll go with. But the calculator will allow you to choose the correct answer here because it will be very close to this one and this one. So just so you know, this and this would be the answer. But the calculator gave 89.88 and 110.12 calculator. So that's it for cutoffs. You would need a cutoff formula if you're going to do it by hand. And if you're not going to do it by hand and use the calculator, you have to know how to use the calculator. The last three problems, 6, 7, and 8, are algebraic problems. And I am basically just going to leave those for you guys to do. Those algebraic problems are pretty much the problems that you see here in the lecture notes. I'll just show you. And you should be able to use the 2-page z-table by now. So, number 6, find the mean when the standard deviation is 6 and 3.75% of the area lies to the left of x equals 85. You will use the 2-page z-table instead of the 1-page z-table that I reflect here. So try your hand at those, and that would be problems 6, 7, and 8. That all involve algebra. And there are some algebraic problems in the textbook as well. So I did do problems 1, 2, 3, 4, and 5. Those are the major word problems. 6, 7, and 8 are algebraic. So I think that you should be able to do those on your own. The next lecture will deal with the final normal distribution called the famous sampling distribution. And that's going to involve some more cutoffs and finding some more probability. But this is section 6.2, and we are done with section 6.2. So we will move on to section 6.3. I hope that you have a blessed day, and I look forward to creating video number 3, section 6.3. Have a great one.